Hello everyone. In this video, we will discuss division of polynomials. This is the continuation of our topic on the operations on polynomials. First, we have here polynomial divided by a monomial. So when we say polynomial, those are algebraic expressions with one or more terms. But if we say monomial, that is specifically an algebraic expression with only one term. So to divide a polynomial by a single term, divide each term of the polynomial by the divisor and combine the results. So let's check our first example. So this is our example. 9a squared minus 5ab minus b raised to 4 divided by 15b cubed. So this is our dividend. And this is our divisor, which is the monomial. So in this description, it says that we will going to divide each term, so this one, by the divisor. So we will divide this by the divisor, then with the second term with the divisor again, until we reach the last term of our polynomial. So what we are going to do is rewrite this problem by separating each term and dividing each term of the polynomial by the divisor, which is the monomial. So 9a squared divided by 15b cubed. So let's copy the operation, which is, or the sign, minus 5ab. Then let's divide that again by the monomial or the divisor, which is 15b cubed. Then for the last term of the polynomial, b raised to 4. Then let's divide that again by the divisor, which is, of course, the same with the previous one, 15b raised. If you will notice, in order to divide this, we will apply the quotient rule in index laws. So meaning, if there are like variables or same variables in the numerator, then same at the denominator, we have to subtract its exponent. So that is the quotient rule. So let's simplify this, or let's divide this. So we can first divide the coefficients or the numerical terms. So 9 divided by 15. So basically, 9 is lower than 15, so we cannot divide that, but we can simplify it. So 9 over 15, or the lowest term for that is 3 over 5. So we will write 3 over 5. Then we go with the variables. So we have a squared at the numerator and b cubed at the denominator. So they are different variables, so we will copy it as is. So a squared over b cubed. Then next, we proceed with the next term. 5 divided by 15, so that is, the lowest term is 1/3. So we will write 1/3. Then for the variables, we have a and b at the numerator. Then we have b cubed in the denominator. So if we apply the quotient rule for the variables, we will copy first the variable a because there is no other variable a at the denominator, so the variable a at the numerator will remain. So we will now proceed with the variable b. So b raised to 1, so there is an imaginary 1 here, over b raised to 3. So by quotient rule, we will subtract its exponent. So that will become b raised to 1 minus 3. So b raised to 1 minus 3. So I will write it that way for this moment. Then the last term minus, so we have here an imaginary 1 as the coefficient, so 1 over 15, so that cannot be simplified further, so we will copy or write 1 over 15. And for the variable, we only have b variable, so we will write b, then we will subtract again its exponent, so that is 4 minus 3. Then let's proceed in simplifying this. So for the first term, this cannot be simplified any further. So this is the simplified form of the first term. So we will write it as one fraction. So 3a squared over 5b cubed. For the second term, so that is 1/3 a, 1/3 a, then b raised to 1 minus 3, so that is b raised to negative 2. Then for the last one, we have here 1 over 15, then b raised to 4 minus 3, so that is b raised to 1, or exponent 1 is imaginary. Then we continue here. So I will copy as is the first term, 3a squared over 5b cubed minus, remember in index laws, if the variable with a negative exponent is in the numerator and we want to make that exponent positive, we will be going to bring it down in the denominator. So we will write 1/3, then the a, so that has a positive exponent 1, so it will remain at the numerator. Then for the b, negative 2, it will go down with a positive 2. Then lastly, we have 1 over 15b. So if we have a 1 as the coefficient in the numerator and it has another variable at its side, we can omit the 1 because it is imaginary. So we can rewrite this in the form 3a squared over 5b cubed minus a over 3b squared minus b over 15. So this is now our final answer. So this is how we divide a polynomial by a monomial. Next, we have the polynomial divided by a polynomial, which we are going to use the long division method. So if we have a divisor that is not a monomial, the method that we are going to use is the long division. We cannot do the previous method because we have a polynomial or a binomial or a trinomial as the divisor. So in the description, it says that to divide the polynomial by a polynomial, use long division. So take note, the division is exact if the final remainder is a 0. So let's discuss the step by answering the first example. So we have here, so this is again our dividend, 38 plus d squared minus 12d divided by d minus 5. So this is our divisor. So if you will notice, the divisor is a binomial, which is, of course, a binomial is a type of polynomial. So we cannot use the previous method because it is a 2 terms already. So the first step in long division is to rewrite the dividend and of course the divisor in descending degrees, meaning we will write first the term with the highest degree, then followed by the next or second highest degree until we proceed until we reach the constant. So remember, we should arrange it from the highest degree until the lowest degree, both for the dividend and for the divisor. So let's arrange this. So for the dividend, we have d squared as the highest degree or the leading term. So we'll write it d squared, then followed by the 12d minus 12d plus the constant 38. So we will use the divide symbol, division symbol, and of course we will write the divisor here at outside the division sign. So the divisor is already arranged, so we will write d minus 5. Then next, so in dividing a polynomial by another polynomial, we will going to the first term of the dividend by the first term of the divisor. So that is our first step. So d squared divided by d. So if we will write that, it looks like d squared divided by d. And we will of course follow the quotient rule. So this will become d raised to 2 minus 1, which is equal to d. So that is how we are going to divide a polynomial by another polynomial. So again, divide first the first term of your dividend to the first term of your divisor. So d squared divided by d. Then we will going to write here at the top the quotient of that operation. So in this case, d squared divided by d is equal to d. So we will going to write here d. Then next, if we have already the first quotient, we will going to multiply this to the whole divisor. So d times d is d squared. And we will going to align that here in the first term. So again, multiply the quotient to the divisor. So d times d is d squared. Then d times negative 5, so that is negative 5d. And we will going to align that here. If we are done multiplying the quotient with the divisor, the next thing to do is to subtract. So we will going to subtract the dividend and the product of the quotient and divisor. So we will going to subtract that. So in subtracting, we will going to change the sign of the terms, then proceed with addition. So let's change the sign of this. So this one, the negative 5d will become positive. Then positive d squared, so there is an imaginary sign here, this will become negative. Then proceed with the addition operation. So negative 12 plus 5. So we are done with the addition on polynomials. So I expect that you already know how to add polynomials. So negative 12d plus 5d, this is equal to negative 7d. Then d squared plus negative d squared, so that will become 0. So we will write here 0. So after we subtract this one, we will going to bring down the next term from the original dividend. So we will going to bring down the positive 38. So we have here the positive 38. And this will become our new dividend. So we will going to divide again the first term of this dividend, which is the negative 7d, with the divisor. So we will only going to get the first term. So negative 7d divided by positive d. So if we will write that, it's like negative 7d divided by d. So by index loss, this will become negative 7d 1 minus 1. So this is negative 7d raised to 0. And any variable raised to 0 that is equal to 1. So meaning, negative 7d divided by d is equal to negative 7. So we will write that here. Then we repeat the next step, which is to multiply the quotient with the whole divisor. So negative 7 times d, that is negative 7d. Negative 7 times negative 5, so both are negative, so that will result to positive 35. Then next is to subtract. So in subtracting, we change the sign. So the positive 35 will become negative 35. Then the negative 70 will become positive 70. Then proceed with addition. So positive 38 plus negative 35, that will become positive 3. Then negative 70 plus 70, that is equal to 0. So when we are going to stop dividing, so let's check. Positive 3 divided by d cannot be divided already because it has lower degree than the divisor, meaning the degree of d here is equal to 0. So there is no variable already. So if we cannot divide the remaining dividend here, so because we cannot bring down other terms from the original dividend, so this is the remaining dividend. If we cannot divide this to the divisor, we will going to stop the division process. And the terms that the term or terms that is or are left here is what we call the remainder of the problem. So how we are going to write the final answer? So in writing the final answer in division, we will first write the quotient, which is this one. So d minus 7, d minus 7. Then take note of the sign of your remainder here. So if it is positive, we will write here positive. So we will write 3 divided by the divisor, d minus 5. So in writing the remainder, we need to divide it by the divisor. So take note, for the final answer of division, write the quotient. So the quotient is what the terms that are found at the top of the division sign plus the remainder. Then the remainder is the term found at the bottom of the process, and don't forget to divide it by the divisor. So our final answer here is this one. So next example for polynomial divided by polynomial, which long division is used. We have here 8x squared plus 2xy minus 3y squared divided by 4x plus 3y. So from the previous example, we have said that we should arrange first the dividend from the highest degree to the lowest degree. But in this case, if you will notice, we have two variables, which is x and y, with the same degree. So if we encounter problems like this, we can use leading term either. So we can use the x squared or the y squared as the leading term. So we can choose between the two. So I will show you in this example that we are going to arrive with the same answer, even though we are going to use different leading terms. But for the first step, we will going to arrange it as the x squared in the start. So we have 8x squared plus 2xy minus 3y squared divided by, so the divisor. So I have written the x squared first. So I will write the 4x term as the leading term also. So 4x plus 3y. So again, let's divide the first term by the first term of the dividend divided by the first term of the divisor. So 8x squared divided by 4x. So that is like dividing the 8 by 4. So that will result to 2. Then x squared divided by x. So that is again quotient rule, or you will going to subtract the exponent of x. So 2 minus 1, which is 1. So that is 2x. Then multiply the quotient by the whole divisor. So 2x times 4x, so 2 times 4, that is 8. Then x times x, that is x squared. Don't forget the next term, 2x times 3y. So these are all positive, by the way. So 2 times 3, that is positive 6. Then x times y, so they are different variables, so we will write it side by side, x times y. Then next, change the sign of these terms, then proceed to addition. So the positive 6xy will become negative 6xy. Then this one, this is positive 8x squared, and it will become also negative 8x squared. Then we proceed with addition. So positive 2 plus negative 6, that is negative 4. Then we copy the variable x, y. 8x squared plus negative 8x squared, that is equal to 0. So you will notice now that the first term, when we subtract, result to 0. So that is always the case when we are dividing. Subtract these terms and your answer is not 0, there is something wrong with your process. So double check your answer. Then next, if we are done on the subtraction part, we will going to bring down the next term. So let's bring down the negative 3y squared. So in bringing down term from the original division, do not change the sign. Okay? Because other students change it, and of course their answer will be wrong. Then after we have the new dividend, we will going to divide again the first term by the first term of the divisor. So negative 4 divided by positive 4, that is negative 1. So I will write here negative 1. Then xy divided by x. So we have x in the numerator, x in the denominator, that will cancel out. So we will be left with the y variable. So I will write here y. So we have 1 as the coefficient, so we can erase that because 1 is imaginary. Then next, the quotient, that should be multiplied with the divisor. So negative y, because we have here the sign negative. So negative y times 4x is negative 4xy. Then negative y times positive 3y that is negative 3y squared. Then, let's subtract again. So, in subtracting, change the sign. So, this one, it will become positive. Then, this one, it will also become positive. So, then we add negative 3 plus positive 3, that is 0. Negative 4 plus positive 4, that is also 0. So we have a remainder as 0, so we call this as exact division. So meaning, our answer here is the quotient itself without the remainder. So the answer is 2x minus y. So we can do the other solution by dividing first the term with the y squared. Then the answer should be the same. So I will write first the negative 3y squared followed by the 2xy plus 8x squared. So I wrote the 2xy for both the solution as the second term because we are dealing with the y variable. So y squared, so the term that should be written next is the term with the y variable. So this should be it at the middle or the second term. Then of course, the last term is the term without the y variable. Then we divide this by right first the 3y plus 4x. Because we use the negative 3y squared as the leading term for our dividend, so our leading term for the divisor should also be the y term. So this is the 3y. Then let's do same process as before. So negative 3y squared divided by the first term, which is 3y. So negative 3 divided by 3 is 1. Negative. So that is negative 1. Then for its variable, y squared divided by y. So that is y. So again, we can erase the, we can erase the 1 coefficient because that will be imaginary. Then next, if we have the quotient, let's multiply this by the divisor. So negative y times 3y, that is negative 3y squared. Again, negative y times positive 4x, so that is negative 4xy. And for the next step, change sign because we need to subtract 8. So let's change the sign. Positive, then this will also become positive. Then let's proceed to addition. Positive 2 plus positive 4, so that will become positive 6xy. Then, negative 3y squared plus positive 3y squared, that will result again to 0. So after we subtract, let's bring down the next term, which is positive 8x squared. Then same, we divide the first term by the first term of the divisor. So 6xy divided by 3. So 6 divided by 3, that is 2. So we will write here 2. Then xy divided by y. So the y variable will cancel out and we will be left with the x variable. Then we multiply 2x times 3y. So that is positive 6xy. Multiply again 2x times 4x. So that is positive 8x squared. Then of course, we need to subtract again by changing the sign. So this will become negative. This will also become negative. Then let's proceed to addition. So positive 8 plus negative 8, that is 0. Positive 6 plus negative 6, that is again 0. So it is the same that we have an exact division. And if you will rewrite the answer, this is the same also with the previous one. We have positive 2x, and this is also positive 2x, and negative y, then negative y. So the answer for the second solution has been interchanged. But mathematically, they are the same. So negative y plus 2x. So that is the other example for the long division that we can use for polynomial by polynomial or polynomial divided by another polynomial. So the same process is used even if we have a trinomial as the divisor. So we in this example, we only use a binomial as a divisor. But if we have a divisor as trinomial, or meaning like this one, so if we have three terms, the process is also the same. We are going to divide only the first term of the dividend by the first term of the divisor. Then if you're done dividing it, multiply the quotient by all the terms of your divisor. Then subtract, bring down the next term, then repeat the process until the term at the bottom part cannot be divided by the divisor. So this is how we perform long division. Next is the polynomial divided by a linear binomial. So if we have a divisor as a linear binomial, we can use the synthetic division. So it's like a shortcut. So if we say linear binomial, so take note with the binomial, there should only be two terms. But it also says here linear. So if we say linear, it is in the form of a line equation. So the highest degree should be 1. So it's like x minus 5, y plus 5, a minus 2. So that is a linear binomial. If we have x plus y, that is not a linear binomial. So we cannot use the synthetic division. So take note, we can only use the synthetic division if we have a divisor in a form of linear binomial. So here are the other examples of the linear binomial. So we can try to solve using the synthetic division by using the first example a while ago, if you remember it. Here. So we have 38 plus d squared minus 12d divided by d minus 5. So this is a linear binomial because our divisor is binomial and the highest degree is 1. Then of course it has the constant. So that is a linear binomial. So the first step is to arrange the dividend in order of descending power. So same procedure as we have done before. It should be written from the highest degrees until the lowest degree. So if if a power is missing, insert a 0 as its coefficient. So meaning, so this is an example. Let's say we have x cube plus x plus 2. So there is a power missing here because there is no x squared. So if there is no x squared in the given, it says that we will going to write a 0. So we will write 0 plus x plus 2. So we will insert 0 in exchange with the x squared. So that is one process here one step here in synthetic division. So in this case, we will going to write first the d squared minus 12d plus 38. Then next, we will going to set up the divisor root. Divisor root meaning, so d minus 5 equal to 0. Then, we will going to transpose the constant at the other side. So that will become d equal to 5. So remember, if we are transposing the constant or any variable at the other side, the sign will change. So that is because of the concept. So d minus 5 is equal to 0. So we want to make this 0. So in order to make this 0, we will going to add here positive 5. But to make it equal, we are going also to add here positive 5. So the final answer now, so minus 5 plus 5, that will become 0. Then 0 plus 5 is 5. So that is the concept of transpose. So let's perform the synthetic division. So after writing or arranging the dividend, we will now going to write the coefficient of the dividend. So we have here d squared. So the coefficient here is 1. So we will going to write the coefficient here 1. Then next, the coefficient of d, which is negative 12. Then the last term, which is positive 38. Then we will going to write here the divisor root, which is the positive 5. So we will write here 5. So the next step, we're going to write here a line. We will going to bring down the 1. So bring down 1. Then next, 1, multiply it by the divisor root. So 1 times 5. So that is 5. And we will going to write it in the next term, align with the next term. So 5. Then next step, we will going to add these terms in this column. So negative 12 plus 5. So negative 12 plus 5, that is negative 7. Then again, negative 7 times 5, that is negative 35. Then repeat, add this column again. So 38 plus negative 35, that is positive 3. So there are no more terms, so this is the end of our synthetic division. And again, this is our remainder. So if you will go back to the long division process, we have there the remainder 3. So how are we going to write our answer in this case? So in writing the answer, so we started with the d squared as the leading term. So our quotient will be d squared minus 1. So that is the first term of our quotient. Or simply, that is, so this is the first term. So that is d. Then, we will copy the first numerical coefficient here, which is 1. So I will write first the 1. Then for the second term, wait, I will rewrite this one. So for the second term, it is d2 minus 2. So that is basically d raised to 0 or 1. So 1 times, we'll write that. So this is the equivalent. So 1 times the coefficient here, which is negative 7. So we will write here negative 7. Then of course the remainder, which is 3. So this is positive. So that is positive 3 over, of course, the divisor. Do not forget the divisor. So for the final answer, because we have 1 as the coefficient, so that is imaginary. So that will become d minus 7 plus 3 over d minus 5. So that is how we answer, or how we write the final answer using synthetic division. Next example, we have here 3a squared minus 7 divided by a minus 5. So actually, you can use the long division here also. But like what we have said a while ago, synthetic division is like the shortcut method if we have a linear binomial as the divisor. So in this case, the divisor is a linear binomial. So we can use the synthetic division. So what we have done a while ago is to arrange the dividend. So in this case, it is already arranged. And you will notice that one term is missing. So the leading term is a squared. So there should be an a term. So a squared, then a, then the constant. But in this given, there is no a. So here, we will going to insert the 0 numerical. So it will like become 3a squared plus 0a minus 7 divided by a minus 5. So that is the arrangement. Then we will going to write the coefficients of the dividend. So that is 3, 0, negative 7. Then the divisor root. So we have here a minus 5 again, so that will become positive 5. So I will write here 5. Then let's draw our line. Next step is to bring down the first coefficient. So that is 3. 3 times 5. So remember, the first term that you have written here will be multiplied by the divisor root. So 3 times 5, that is 15. Then we will write it at the second column. So that is 15. Then we will add this column. So 0 plus 15, that is positive 15. Then 15 times 5, that is positive 75. So we write here 75. Then let's add this again. Negative 7 plus 75, that is positive 68. So again, the last term is the remainder. So this is our remainder. So in writing the answer, so we have started with the a squared. So our first, or the leading term of the quotient now will be decreased by 1 in its exponent. So a squared, and it will become a. So that will become a. Then we will copy the numerical coefficient. So that is 3a. Then next, so if the first term in our quotient is a, the second will be constant only. So that is 15, or positive 15. For the remainder, we have here positive 68. So we'll write here plus 68 divided by the divisor, which is a minus 5. So that is how we perform synthetic division. So I will show here at the other side if we want to perform using the long division. So I will write the dividend 3a squared minus 7 divided by a minus 5. So I will divide first the leading term of the dividend by the first term of the divisor. So 3a squared divided by a, that is 3a. Then 3a times a, that is 3a squared. Again, 3a times negative 5, that is negative 15a. Then we subtract. So by subtracting, let's change the sign. This will become positive. This will become negative. So positive 15a. So if you will notice, the one at its top is a constant. So we cannot combine these terms. So it is the rule between like and unlike terms. So these are unlike terms. So we will copy it as is. So it will become positive 15a. Then we will bring down the negative 7. Then for this one, 3a squared plus negative 3a squared, that will become 0. So we have already bring down the negative 7. So we will going to proceed with the division process. So 15a divided by a, that is positive 15. So next, multiply 15 times a. So that is 15a. Then 15 times negative 5. So that is negative 75. Then we subtract. So let's change the sign first. So this will become positive. This will become negative. Negative 7 plus 75, that is positive 68. Then positive 15 minus 15, that is 0. So if you will notice, we have the same remainder, which is 68. Then we have a quotient here, 3a plus 15. So either solution or method can be used if we're dividing a polynomial divided by a linear binomial. So next example, and the last example for the synthetic division. So again, let's rewrite the dividend by writing first the term with the highest degree. So that is 4x cubed minus 8x squared plus 13x minus 5. Then our divisor root, that is 2x minus 1 equal to 0. So let's transpose the negative 1. It will become positive 1. So take note, if we're getting the divisor root, the variable here should be, the coefficient of the variable here should be 1. So in this case, there is a 2 as a coefficient, so we need to divide this by 2. So we need to divide this by 2, and if you divide this by 2, you need to divide the other side by 2 also. So our divisor root now is 1/2. So take note of the difference. If we have a coefficient of the linear binomial 1, we were going to follow the previous example. But if we have a coefficient of 2, 3, or any other numerical value, we need to divide the constant by that coefficient, because we need to have a coefficient of 1 for our divisor root here for the variable. So here we have 2x minus 1, so we need to transpose the 1, so it became 2x equal to 1. Then divide both sides by 2, so we have now divisor root x is equal to 1/2. So let's proceed with the synthetic division. So let's write the coefficient. We have 4, negative 8, positive 13, minus 5. Then the divisor root, we have 1/2. Then let's proceed with the synthetic division. Bring down 4, then multiply this by 1/2. So 4 times 1/2, that is positive 2. Then next, we add. So add these terms. So negative 8 plus 2, that is negative 6. Then negative 6 times 1/2, that is negative 3. Then again, add this column. 13 minus 3, that is positive 10. Next again, 10 times 1/2, so that is positive 5. Then add the last column. So negative 5 plus 5, that is 0. So we have 0 as the last term, meaning this is an exact division. So we do not have a remainder. So in writing our answer, so we have here x cubed. So our first variable for for our final answer should be decreased by 1. So that will become x squared. Then we copy the first coefficient, which is 4. Then we have here negative 6. So that is negative 6. Then we will going to decrease this again by 1. So that will become x. Then we have here positive 10. So positive 10. Then decrease this again by 1. So it will become x raised to 0, or simply numerical 1. So this is constant. But this is not the final answer. If we have divided our divisor root by the coefficient of the leading term of our divisor, we need to divide this answer by the coefficient of our divisor. So if in another example you have 3x, you will going to divide the answer by 3. But in this case, we have a 2 as the leading coefficient of the divisor, so we will only going to divide this by 2 to get the final answer. So let's divide this by 2. So our final answer now is, so 4x squared divided by 2. So this is like dividing a polynomial by monomial. So if we have a problem like this, we will going to divide each term by the monomial. So I will rewrite it. So 4x squared divided by 2 minus 6x divided by 2 plus 10 divided by 2. So for the final answer, 4 divided by 2, that is 2. Then let's copy the variable. Then negative 6 divided by 2, that is 3. Copy the variable x. 10 divided by 2, that is positive 5. So this is our final answer.